How do I go? What we do now? You get reload here. All right, you're welcome back. Okay, so we are still on our discussion of the exercises of Maths 101, and then we have joined into the part 2, and we've journeyed from question 1 to 6 in a pre-recorded video which I will upload later today. And then we have also gotten into in our last section we looked at our last live section we looked at questions 7 through 14. Okay, so, and like I said, this particular section has about 19 exercises, and so we are going to be looking at the remaining exercises in this section and then probably begin for part 3. Okay, so quickly let's get into it. Okay, so for number 15 now, which is the next. So this now, the last questions we looked at considered topics of permutation and combination. This one now is beginning with the concept of binomial theorem or binomial expansion. Okay, so let me write that here. Of course, this is one of the topics of Maths 101, and of course of A-level maths. So any other person can actually find this study that we are doing very helpful. Okay, so let's go ahead. Now, this is the question. It says that to expand, okay, let me read it. To expand x plus 2y raised to the power of 4, certain terms are omitted. Provide them. Okay, and this is what they gave us. So they gave us something of this nature. This is equal to the sum from n equal to 0 to 4 of 4 combination n. Then as x is raised to the power of 4 minus n multiplied by 2y raised to the power of n. Okay, so of course this is the general formula for binomial expansion, which we can actually call the binomial theorem or binomial definition. Okay, so it says that if we have something like x plus y raised to the power of n, that it is equal to the sum of from r equal to 0 to n of combination of n to r, and then x to the power of n minus r multiplied by y to the power of r. So this is the general formula, and that's what was used to get what we have here. In this case, your y is 2y and your n is 4, while they represented your r here with n, which is for me, I used r. Okay, so any of that. So now they now did this expansion. So remember that it is a sum from n equal to 0 to n equal to 4. So let's start. So the first one was 4 combination 0, which, I said you can write combination this way. 4 combination 0. This and this are actually the same. All right. So so they chose to use this one. X raised to power 4. Of course, this is the first one where your n will be 0. So even if you raise 2y to the power of 0, it will give you 1. So this is what you're going to have here eventually. Plus, let's use another one here. So they now have 4 combination 1. Remember, your n will be increasing by 1. And so the next one is going to be x to the power of 2. Is it 2 or 3? It's 3 now, because it will be 4 minus this n. So here will be 3. Then 2y now raised to the power of 1. And I think that's the only thing it was missing here in your material. So it was missing here. So you are going to fill in here with 2y raised to the power of 1. You can put that power there just for emphasis sake. Then plus the next thing will be 4 combination 2. And then it will be x raised to power 4 minus 2, which is 2. That's what they have. Okay, that's actually what was missing here. Okay, so there's a box here, and then the other one was 2y to the power of 2, because the power of 2y will always be the value of your n here, and then plus okay, the next one is 4 combination r, which is 3, 4 combination 3, then x will be 4 minus 1, so power 1. Then you now have 2y to the power of 3. That's not the last one. So the last one, they actually gave a box entirely, so you are to fill in the last one, and I'm going to be doing it down here. So it's going to be 4 combination 4. Remember we said you're joining from n equal to 0, 1 up to 4 here. Okay, so the next one will now be x to the power of 0, which is 4 minus 4. So that x will actually disappear from there, and you will only have 2y to the power of 4, which is what you have here. So this is actually what will fill in the bracket, the last box here in that your material. Okay, and that is for number 15. Okay, so we move over to number 17. Sorry, number 16. So for number 16, they said we should find the coefficient of x to the power of 10. Let me put that. The coefficient of x to the power of 10 in the expansion. So this particular expression was expanded. 2x minus 3 raised to the power of 14 was expanded, and we're asked to find the coefficient of x to the power of 10. Okay, so and they offered some hints here which I would like to explain to us. So what are you expected to do? From the formula above here, that's that's what we have here. You will notice that there are a number of remarks I'm going to make when it comes to combination, and one of them is that for each term that you have here, you can see all the about 4 or 5 terms that we have here. In fact, it's 5. In fact, that's one of the remarks, that the power of your expansion will determine the number of terms you have. So if your power is 4, so your number of expansion is always 1 more than the power. Okay, so if the power is 4, so that means I'm expecting 5 expansions. That's I'm expecting there are 5 terms in the expansion, and rightly you have 1, 2, 3, 4, 5, which is this one. Okay, now for each term, the sum of the powers of the terms that you expanded is always equal to the total power you have here. So here you can see your 2y here, the power was 0, so we didn't write it. So 0 plus 4 is 4. You can see 2y, the power here is 1. 1 plus 3 is 4. The power of 2y here is 2, plus this 2 is 4. Just like that, okay? So that's one thing you should note. And that's what you're going to apply in solving this question. So to get the coefficient of x raised to power 10, so I will need this term to have a power 10. Because if it has a power 10, let me say 2x to the power of 10. So it means I'm going to get 2 to power 10 times x to power 10. So it is this one that will help me get x to the power of 10. Okay, so see what you're going to do then. So what it means is that my 2x should be to the power of 10. So if my 2x is to the power of 10, it means that the second term here, which is going to multiply, that's minus 3, is now going to be to power what? So remember that the total power should be the power we have here, which is 14. So that means this one should be to power 4. Okay, so I've gotten the 2 terms. I now need to get the ordinary numerical coefficient here, which is gotten from this combination. And how do you get that? Remember that your combination is always the highest number here, which is 14. So it's going to be 14 combination. Now, what is usually below here is the power of the second term. Look at it. Here 0, the power of the second term is 0. Here 1, 1. Here 2, 2. Here 3, 3. Here 4, 4. So the power of the second term determines the R of your combination. And so here is going to be 4. Okay, so, and that's exactly what they did for us. So they said that the term needed is 2x to the power of 10 multiplied by minus 3 to the power of 4. That's the first hint they gave. Okay, then they now say by binomial theorem, this is the fifth term, okay, in the expansion of this, and is given by, okay, they asked us to determine the number of term. Okay, so actually it is the progression of the question that determines what we solve. So they said by binomial theorem, this particular term will be what term? Okay, so it's going to be the fifth term. How do you know that it is the fifth? Come back here. Your R will always determine it. See the R here. This is, remember, this is n combination R. That's why I'm calling this R. So your R, the first R is always 0. So for the first term, your R is 0. For the second term, your R is 1. For the third term, your R is 2. For the fourth term, your R is 3. And for the fifth term, here your R is 4. So it is the R that determines the position of the term. So since the R here is 4, it means that this is the fifth term. So you just add 1 to it. So this is the fifth term of the expansion. Okay, and that is going to fill that space there. Okay, and so in going forward, what okay, so in going forward, all you now need to do, remember, sorry for that break. So remember, we are asked to get the coefficient of this. So in going forward, all we need to do is to now simplify this to get our solution. And if you go to your material, you will see that they wrote this as 14 combination 10, and then 2x raised to power 10 and minus 3 raised to power 4. And if you are not careful, you would want to be confused. You don't have to be confused. Actually, it's supposed to be 14 combination 4, but they chose to write 14 combination 10 because they are equal. Remember, I told you up there that under the concept of complementary combination, that, for example, 3 combination 1 is equal to 3 combination 3 minus 1, which is 2. 10 combination 7 is equal to 10 combination 10 minus 7, which is 3. So that means 14 combination 4 is the same thing as 14 combination 14 minus 4, which is 10. So I think that is why they wrote that there. So it doesn't still change your solution. So you just have to evaluate this, and to do that, you are going to have that this is equal to 14 factorials all over 14 minus 10 is 4 factorials, then multiplied by 10 factorial. And that is going to be multiplied by, this is going to give you 2 to the power of 10 multiplied by x to the power of 10. And then finally, here is minus 3 to the power of 4. And of course, since the power is even, the minus will disappear. So you have 3 to the power of 4, which is 81. Okay, so that means this is going to give us, so I can expand this. So if I try to do that, I'm going to get 14 times 13 times 12 times 11 times 10 factorial. And this is all over 4 factorial is 24. and that is times 10 factorial. So I don't need to expand that one because this will cancel this. So let's move on. And then you have 2 to the power of 10 multiplying your 81. So what is 2 to the power of 10? Let me try to get that. 2 to the power of 10. Okay, that is 10424, then multiplied by 81, then multiplied by x to the power of 10. So that means the whole of this is going to form the coefficient of x to the power of 10. And so let's quickly simplify that. So what is it going to be? So here let's try to see if we can cancel out. 12 can cancel out 24 to give you 2, and 2 here will cancel out 14 to give you 7. So we now have of course we now have 1024, which is this, multiplied by 81, then multiplied by 7, then multiplied by 13. You have 13, and finally multiplied by 11. So when you multiply by 11, so that gives you your final answer as 83,026. This sounds like money. 026 and 944. So this is the coefficient of x raised to the power of 10 in that expansion. Okay, so I hope that made sense. All right, so that's the solution for that, which is number 16. So we go over to number 17 now. Okay, so for number 17, what do we have? We are given, excuse me, okay, so sorry about that. So for number 17, this is the question we have. We are told that n combination n minus r is always equal to, I think I just said it some minutes ago, is always equal to your n combination r. We call this complementary combination. So complementary combinations. Okay, so your combination has a complementary property. Okay, or you can just say complementary property of combinations. Okay, so that's that. So and then we go over to the next one, which is number 18. So they said in the expansion of a plus b raised to the power of n, the second term is, okay, remember that from that general definition, you start from n combination 0, and then your a would take power n minus 0, which is n, and your b would take power 0, plus you go to n combination 1, and then your a would take power n minus 1, and your b would take power 1. And then the third one is n combination 2, and your a would take power n minus 2, and your b would take power 2, and so on and so forth, until you get to n combination n, and then your a will take power n minus n, which is 0, and your b will take power n. So that's the progression. And if that is okay with you, so you could see that the second term is nc1 a to the power of n minus 1 times b. Okay, and that's what they wrote here. And they said the third term is nc2, which you have already captured here. nc2 a to the power of n minus 2, then b to the power of 2. So they now asked for the fifth term. They loved fifth term a lot in this material. Okay, so the fifth term is very simple. nc4. Remember, like I said earlier, your r is always 1 less than the term, the position of your term. So here this is first position, so the r is 0. Second position, r is 1. Third position, r is 2. So for fifth position, r will be 4. So that means a to the power of n minus 4, then multiplied by b to the power of 4. So this is the answer for number 18. Okay, so you could see that this number 16 down to 18, 15 down to 19 are not difficult questions. So let's look at the last number in this section. So that number says that there are about 2 questions. So the first one says, find the term. Let's write it. Find the term that is independent. That is independent of x in the expansion of x minus 2 over x all raised to the power of 8. Okay, so this is what they're asking us to do, to find a term that will not contain x if you expand this guy. Okay, so it's a very beautiful question, and of course you pay attention and we can go through it. So all of this will rise and fall on some of the remarks that I've given you earlier on, which says that the power of the sum of the powers of these, for instance a and b, must be equal to the total power you are given to expand. So like here you can see n minus 4 plus 4 will give you n. Okay, so that's the principle we are going to apply here. So we want a situation where, if remember here, the first term is x and the second term is minus 2 over x. Okay, so whatever I raise the power of x to will determine what the power of this one will be. Okay, so now I need a situation where the power of this x is going to be the same as the power of the x below, so that the two of them can cancel out. That is how I am going to get a term that does not have x. Okay, all right. So, and how do you get that? So having in mind that the sum of the powers must be the same, so I can start. So I will start by writing my x and then giving it a power. So I am now asking, what power will that be? So you discover that the power that will do that will be power 4. So if my x is to the power of 4 and I have 2 over x, what will be the power now? Remember, the sum must be equal to 8. So this one will also be 4. So you will discover that if you open these brackets, you will get x to the power of 4. And now, remember that the power of this is even. I said it earlier, so the minus will go. So this is going to be 2 to the power of 4, which is 16, all over x to the power of 4, which is x also to the power of. So at this point, their powers are the same, and they can cancel out, and you will get only numbers without x involved. But however, this is not the only term you are looking for. There is also the combination part. And what's going to be the combination part? Remember, it starts with 8, the highest power, and then c, then it will take the power. The r will be the power of the second term. So it's going to be 8c4. So this is the term that you are looking for. Okay, so, and they just asked you for the term. So you can just tell us that, therefore, the term is this. And it will be good to say the position. So what position is this term? That is the 5th term. So it is the 5th term, and it is equal to 8c4 x to the power of 4, then minus 2 over x to the power of 4. And it's good that you stop here. Now, but the second question now says that you should determine the value of that term. So you can now decide to now solve this and then get a value for this. To solve is just to simplify the combination and then this bracket. So let's quickly do that on another page. Okay, so for I, we are told to determine the value for that term. So which we are given as 8 combination 4 x to the power of 4 into the bracket of minus 2 over x to the power of 4. So let's begin. What is 8 combination 4? That's 8 factorial all over 8 minus 4, which is 4, then times 4 factorial, then multiply by x to the power of 4 into, remember I said we can discard this minus because the power here is even. So this is going to give us 16 all over x to the power of 4. And immediately my x to the power of 4 will remove this x to the power of 4. So I just have 8 factorial. I can expand it to 8 times 7 times 6 times 5 times 4 factorial. Okay, so here we have 4 factorial all over another 4 factorial. So I can leave this one. Then I can expand this other one, which is 24. Okay, so why did I leave this one? So that it can cancel the one up, and then multiplied by, I just have 16 up here. All right, my x has disappeared, which is what the question required. Okay, so now I can still cancel out some things. What are those? Of course, 8 can cancel 24 to give us 3, and 3 can cancel 6 to give us 2. So we just have 7 times 2, which is 14, and 14 times 5 is 90. So we have 90 times 160. Okay, we can do, 90 times 60. Okay, is that 90 or 70, please? Okay, look at it. 2 times 5 is 10. 10 times 7 is 70. Please, not 90. That's 14 times 5 is actually 70, not 90. Yeah. Okay, so you are multiplying 70 by 16. So that could be 160 by 7. And so this is 0, 42, carry 4, and then 7 plus 4, 11. So that will give you 1120 as the value for that term that you're looking for. And that is the second part of this particular assignment, number 19II. Okay, so by the first method, they told you to list out all the terms. So they expected you to do expansion of everything. Okay, so let's try doing that. So there they gave us x minus 2 over x all raised to the power of 8. And so they want you to list out all the terms. Write out the one that is independent of x. So let's list out all the terms. So that's going to be 8 combination 0 multiplied by x to the power of 8. The second term will be to the power of 0, so no need. So you have 8 combination 1 x power 7, then minus 2 over x to the power of 1 plus 8 combination 2, then x to the power of 6 minus 2 over x to the power of 2 plus 8 combination 3, x to the power of 5, then minus 2 over x to the power of 3 plus again 8 combination 4, x to the power of 4 minus 2 over x to the power of 4, then plus 8 combination 5, x to the power of 3 minus 2 over x to the power of 5 plus 8 combination 6, then x to the power of 2, then minus 2 over x to the power of 6, and then 8 to the combination 7, x to the power of 1 minus 2 over x to the power of 7, and finally 8 combination 8, x to the power of 0 will disappear. Then you just have minus 2 over x to the power of 8. So from what we just said earlier, you will discover that only this term here is going to be independent of x. This one already has x to the power of 8. This one, when it cancels, x to the power of 6 will remain. This one, when it cancels, x to the power of 4 will remain. Here, x to the power of 1 will remain. Here, no x at all. Here, x to the power of 2 will remain in the denominator. Here, x to the power of 4 will remain in the denominator. X to the power of 5 in the denominator. X to the power of 8 in the denominator. Sorry, here is x to the power of 6 in the denominator, and this one is 8. Okay, so, and this is the term without x. So they said we should write it out, and of course you do that. And then in the second method, they now said we should use what is that. Okay, so there is a formula here. They say let the term be term r. Okay, so by question II, the quantity in this r term is given by, okay, which I already said before. So they said a number of things. Let me write it out. So it's given by 8 combination r minus 1. Okay, since the term is r, okay, I'm dealing with the second method now, as in the material, so that you'll be able to finish up there. So they said let the term be the r term. Let it be term r. That means fifth term or sixth term or whatever. So let the term be the r. Remember we told you that if it is r, then you are going to have 8 combination. Whatever you have here is always 1 less than the term, the position of the term. So here will be r minus 1, and that is 8 raised to the x raised to the power of 8 minus whatever you have down here, which is r minus 1, then multiplied by minus 2 over x raised to the power of whatever you have down here, which is still r minus 1. Okay, so now he says we should simplify that, which they did, and gave us, excuse me, okay, So in simplifying that, they gave us x to the power of 8 minus r minus 1, then multiplied by minus 2 over x to the power of r minus 1. And they said this is the same thing as minus 2 to the power of r minus 1 multiplied by x to the power of 10 minus 2r. And how did they get that? Very simple. If you split this, you are going to get minus 2 to the power of r minus 1 all over x to the power of r minus 1. And remember, it's multiplying this one. X to the power of 8 minus r minus 1 is a multiplication. And of course, this multiplication, this one now is a denominator, so it's dividing this. And if they divide, you are only going to have x to the power of 8 into r minus 1. Now, since their bases are the same, you just subtract the powers. So this will be minus r minus 1 again. So I'm just trying to simplify the x. Of course, you can see where this one is coming from. I want you to see where the other one was gotten. Okay? So if you now open the brackets we have there, you have 8. This is going to be minus r plus 1. This one will also be minus r plus 1. And that is going to give you x to the power of 8 plus 1 is 10. And then minus r will give you minus 2r. So that's actually how they got this. Remember that we have omitted the value for this combination at that point. Okay, so what next was done? So they now said for this term to be independent of x, it means that your 10 minus 2r must be equal to what? So must be equal to, you are going to have okay, yes. So for it to be independent of x, then this power of x on the right hand side must be equal to this power of x on the left hand side. It must be equal to this one, only this one. Okay, so that means 10 minus 2r must be equal to 8 minus r minus 1. And if you work on this, so they now asked us to solve it to finish up. So which is going to be 10 minus 2r equal to 8 minus r plus 1. And this is going to be 10 minus 2r equal to 9 minus r. Collect like terms. Let 9 come here and let 2 minus 2r come. That will be 10 minus 9 is equal to minus r plus 2r. And that is going to give us that r alone is equal to 1. Okay? And then, of course, if you substitute it back here, you will see that you will get exactly what we talked about before, which is 8r, which is okay, let's look at this carefully so that we don't make mistakes there. Okay, so see that here you can see that your 10 to the power of minus 2r is the power of x on the right hand side. So for the term to be independent of x, that means this should actually be equal to 0, not what you have on the other side. Sorry about this. This should be equal to 0. That's how the term will be independent of x. Please, sorry about that. Why will it be 0? Because if the whole of this becomes 0, so you just have x to the power of 0, which is 1, and so it disappears, and then there is no x at all. Sorry about that mistake. So it means that, in that line they said for this term to be independent of x, 10 minus 2r must be equal to dash. So it should be equal to 0. That's the only way this x will change to a number. And so immediately you can have 10 is equal to 2r if you bring this over here. And if you divide both sides by 2, you are going to get that your r is equal to 5. Okay, so, and that is the one that when you substitute here will give you exactly what we got earlier on. If my r is 5, I'm going to get 5 minus 1 will be 4. Then here I will have x to the power of, if I put r as 5 here, 5 minus r is 4, sorry, minus 1 is 4, and 8 minus 4 will give me 4 into the bracket of minus 2 all over x raised to the power of 5 minus 1, which is also 4 again. So this is exactly what you need, to get the term that is independent of x. Okay, so this is the second method which they asked you to use to complete that exercise, and it is in the II. So that completes the the part 2 for us, and we got our r there as 5. Okay, so that's the completion of exercise 2, part 2 of this exercise, which you call module 2. So this is for number 19. I hope I wrote 19 there. Yeah, 19II. Okay, so you go to, yes, this is a 19I. Okay, 18, 17, 16, and 15, which was where I started. Okay, so we are going to end here for this session again, so that when we begin the next session, we will now get into the module 3, which is the last part of the exercise. The module 3 is not that plenty. It's just about 15 questions, and we hope that a section should handle it. All right, so have a very nice time. Good that you joined the class, and those of you who didn't join will have time to see the recorded section for this particular part of these exercises. All right, see you in the next section. Bye. Class will be the